Today's lesson is A102. We're going to solve systems of equations by substitution, part 2. What's our objective? Get ready?
Solving systems of equation by substitution, part 2.
Very good. I'm going to give a ticket for Jacob because he's so good at full response. I appreciate that. Lucas, I apologize. So today we're going to talk about how to solve by substitution when it's a little different. We've already done substitution. What's different today is one of the variables is not already isolated for us. We're going to have to isolate a variable. So let's just practice, make sure we understand. If I had x minus 3 equals negative 8 and I needed to isolate x, I would do inverse operations and I would add the 3 to both sides. Well, what if I had x minus 3y and I needed to isolate x? I would do the same thing. I would use inverse operations and I would add 3y to both sides. This would eliminate or cancel because it adds up to 0. I would copy down my x. I'd copy down my equal sign, and I'd have negative 8 plus 3y. They're not like terms. What are they? Get ready?
Not like terms.
They're not like terms or unlike terms. This is like $8, and this is 3 yo-yos. You can't add dollars and yo-yos together. So they're different. So I'm going to write negative 8 plus 3y. So I've isolated x. Well, what if it looks like, what about this one? If I wanted to isolate y, I need to get rid of the negative 5. What's the inverse of that? Alex?
5.
It'd be 5. So what do I do to it?
You multiply it by itself. Well, I mean, no. You would times by 1. Just
You're thinking to get rid of, but think of it as a subtract 5 or a negative 5. What's opposite of negative?
Positive.
Positive. So I'm just going to positive 5 it, which is like adding it, right? Okay, so I'm going to add. So they eliminate. I'm left with y. 2 plus 5. This time I can, because they're like terms. Now I threw an x in there. How would I do this one where I need to isolate y? How can I get rid of this negative 5x? Spencer?
Add 5x to both sides.
Add 5x to both sides. Negative 5x plus 5x is 0. I've had a couple students try to make this 10, so be careful. The reason why we do this is because they're an eliminating pair. They turn to 0. So here we get y equals 2 plus 5x. Is it 7x or is it 2 plus 5x? Kate?
2 plus 5.
It's 2 plus 5x. Be careful. They're not like terms. So that means this is $2 plus 5 x-rays. I can't add dollars to x-rays. They're just unlike terms. So keep them separate. But once I have y isolated, I can use y to substitute it anywhere I want. And why would I do that? Because I want everything in terms of one variable. If I have an equation with 2 variables, let me clean this up. If I have an equation like this with 2 variables, I can't solve it because I have 2 different variables. But if I could change everything into like x's and x's, I could solve that. Then I can like simplify and combine all the x's and find out what x is. So the whole goal of this is to get rid of one of the variables so everything's in terms of the other variable. So let's do that. Do I want to isolate this x? Should I isolate this y? Should I isolate this x? Or should I isolate this y? The easiest choice is the best choice. It's this one. Okay? I want to isolate this x because there's no coefficient in front of it. It's already positive. I'd have one step to do, and wham, x is isolated. So I'm going to write it down. I'm going to write it over here. Just right here. X equals negative 8 plus 3y. So I just isolated x. What did I do first? Get ready?
Isolate x.
Isolate x. So that's our first step. We just get rid of one of the, we just isolate one of the variables. So now in this, I've isolated x. Now I need to substitute this into my other equation in for x. So instead of writing an x, I'm going to replace it with what x equals. So rewrite your second equation. Or sorry, that's my other equation, but it happened to be my first, listed first. Instead of writing an x, I'm going to write what x equals. So x equals negative 8 plus 3y. Now from here down, we've already done this. This is old stuff, but we're still kind of practicing and learning and getting stronger at it, so we're gonna review. We distribute. 2 times negative 8 is negative 16. 2 times 3y is plus 6y plus 8y. I copy down the rest. Combine like terms. 6y plus 18y is 14y. Copy down the rest. We're working vertically, staying neat and keeping everything lined up. Then I gotta isolate y. So I peel back my onion layer, one peel at a time. I start with my outermost peel, use inverse operations. They cancel, and I'm left with 14y equals 28. What do I do next? AJ?
Divide 14 on both sides.
Divide 14, excellent. What does that give me, AJ?
Y equals 2.
2, very good. Now that I know y equals 2, what do I do to find x? Kenzie. I've got these two equations. I even have a third equation. I know what y is. How can I find x? Kind of. Are you thinking about using this one? So can we substitute the 2 in for y right here? Okay, so this equals 2. So I'm going to write x equals negative 8 plus 3 times 2. So I'm going to replace y with 2. And I get negative 8 plus 6. Mentally, what is it? Get ready?
Negative 2.
Negative 2. Good. So x equals negative 2. Now we should do a check step, just to make sure. Did we do it right? So if I let x be negative 2, and I let y be 2, are these equations true? Is negative 4 plus 16 equal to 12? Oh yeah, that one worked out. How about this one? Negative 2 minus 6, is that equal to negative 8? Yeah, that worked out too. So we say check. I got it right. So we know beyond any shadow of a doubt we got the right answer. So do that on your test, in your homework. You can check it to make sure it's right. All right, let's try another one. I'm going to call in more students to help this time, so be ready. All right, we've got a system of equations. We're solving by substitution. My first step is to isolate a variable. Which, should we isolate this one? Should we isolate this? Should we isolate this? Or should we isolate this? Pick the easiest one. What do you think is the easiest one, Chelsea? I agree. I totally agree. This is the easiest one. It's positive and there's no coefficients with it. Perfect. Good choice. So how would I isolate it? Stacia?
You
Add x. Perfect. So that leaves me with y equals 2 plus x. That's my new third equation. I'm going to come back to that. What do I do with that? All right, Kenna?
Do you substitute for the top equation?
Substitute it in the top equation. What's my next step, class? Get ready?
Substitute it in the top equation.
So I'm basically going to put 2 plus x right there. So I'm going to rewrite the top equation, leaving a space holder for the y. And instead of y, I'm writing what y equals, which is 2 plus x. Okay, what do I write next? Lucas.
So you write negative x plus 4 plus 2x equals negative 1.
Perfect. Okay, what do I do next? Joseph.
You would add
Like terms. There's a like term. Okay, what does that give me?
3 or negative 3x.
Close.
Or just
Yeah, negative 1 and then I add 2 to that.
1x.
1x, perfect. Plus 4 equals negative 1. Just to save time, I'm going to go ahead and just finish it out real quick. Subtract 4, we get x equals negative 5. Oh. Hey, what do I do with the negative 5? I know x. How do I find out y? Spencer.
You use the third equation and substitute negative 5 for x.
I like how you saw that use the third equation because I've already got y isolated. So if I want to know what y is, if I put the negative 5 in here, It's like that fast. 2 plus negative 5. 2 plus negative 5. Think. Get ready?
-3.
Uh-oh.
-7.
Uh-oh. -3, right? I'm starting at 2, and then I gotta back up 5, so -3. So I can write it as an ordered pair, -5, -3. All right, any questions? Okay, I think I have one more. I'm gonna let you do this on your own, on your papers. Copy this down. Isolate a variable, put your pencil up after you've solved it, and check your answer. Maybe Mrs. Belknap can come around and we'll check. Okay, that took a lot of steps, it took a lot of time, but I loved how diligently everyone was working on it, but we gotta go through it really quick, so you guys have some homework time. Bethany, what variable did you solve for? This one or this one? You did this one? Okay, I think that's a great choice. So if we isolate x, we're gonna subtract 3y. Subtract 3y. Let me just take a quick vote. How many of you isolated this x? 1, 2, 3. Okay, okay, most of you. That's a good choice then. Okay. So they cancel. We left with x equals 2 minus 3y. Now we take this x, we're going to substitute this into the other equation for x. We're going to replace x with this. So I'm going to rewrite the top equation. I'm putting a placeholder. And instead of the x, I'm writing what x equals, which is 2 minus 3y. I'm just going to put an arrow so you see what I did. This is the step I'm worried about. Some of you, raise your hand if you have any questions right here on this step. Okay? Okay, what would I do next, Tyron?
Well, you would then do the multiplying. You'd get -4 plus 6y.
Okay, I'll copy the rest down. Colin, what would I do next? Okay, I'm writing your name down for talking.
Subtract y.
No, I'm going to combine like terms,
Combine like
which is what?
which is 7y.
7y. Okay? So now, and then I need to peel back my onion layer to solve for y. I'm going to add 4. Add 4. I get 7y equals 14. Are you okay?
Yeah.
Do you need to take a little time out? Need to get something figured out?
No.
Okay. So then I'm going to divide by 7, and then y equals 2. How do I solve for x now that I know y equals 2, Spencer?
Well, I sort of solved for both individual variables,
Okay.
but well, like you can solve for x by just plugging in what y equals in the equation with x.
So we're going to plug y right into here. So we're going to make this a 2. 3 times 2 is 6, so 2 minus 6 gives us -4. So now I've got my two solutions, -4 and 2. So give me a thumbs up if you mostly understand it. Hiram? Give me a thumbs down, totally lost. Joseph? Kenzie? I'm asking for a vote. This is how I know if you're understanding or not. Okay, this helps me. Okay. All right, so let's let you guys practice. We're gonna, Mrs. Belknap and I will walk around. We're on 8:26. So take a step, 20 seconds, stand up, right, go.